Hello friends, welcome to my channel Sense Biology. In this video lecture, we are going to discuss about the Mendelian disorders and the difference between autosomal recessive and autosomal dominant disorders. So let's first understand what is the cause of the Mendelian disorders. Remember, the Mendelian disorders are caused due to alteration or mutation of a single gene. When it occurs in autosome, alteration or mutation of single gene, when it occur in autosome, it is called autosomal disorder, which can be divided into two different types, the autosomal recessive and autosomal dominant disorder. So first we will discuss about the autosomal recessive disorder. So to cause any autosomal recessive disorder, the individual should be affected the two genes means one from the father and another from the mother should be affected. When both the alleles are affected, at that time only the individual is said to be affected with an autosomal recessive disease. Okay, so autosomal recessive disease occurs when here the dominant character is healthy because it is recessive. The disease character is recessive. So disorder is the recessive character. So when two alleles or two genes from both the parents are having the abnormality, it will be carried to the offsprings. So the examples of the autosomal recessive disorders are sickle cell disease, cystic fibrosis, PKU means phenylketonuria, and albinism. So these are the four different examples that are most commonly used to describe autosomal recessive disease or disorder. So here we have three different conditions. Clear? So what are the three different conditions? One is capital H, capital H. Here both the H's are capital when the condition is homozygous dominant, means the individual is healthy. Okay. Next, capital H, small h. So these are the two alleles from different parents. Okay. Do not confuse about this. So capital H from one parent and small h from another parent. At that condition, the offspring or the child will be heterozygous healthy or a carrier of the disorder. So this individual is not affected with the disorder because it is autosomal recessive disorder. So here the individual is said to be carrier because it carries the defective gene but is not affected with the disorder. Finally, small h means homozygous recessive disorder. Here the individual or the offspring is affected because both the parent have affected genes. So in this case the condition will be homozygous recessive or the disorder is seen in the offspring. Clear? So now we will go for the autosomal dominant disorders. Here the gene responsible for causing the disorder is dominant over the healthy or normal gene. So here we can say only one gene, if only one gene is affected, means the individual is diseased. So disorder is dominant here. Here healthy was dominant, but here disorder is dominant, and healthy is recessive. Disorder dominant, healthy recessive. Clear? So the example here is Huntington disease, and here also there are three different conditions. I will say the first one, capital H means the condition is homozygous dominant or the disorder is found. In this case the disorder is severe. So severe version of disorder is found here because disorder is dominant here. So capital H are dominant, and when both the alleles from both the parents are having the defective gene, then the condition will be homozygous dominant homozygous dominant, and the condition will be severe, and this will lead to death of the individual during early age. Secondly, we have heterozygous disease or degenerates. Here one allele is having the disease and another is normal, but here as the degenerate is dominant, so here also degenerate is seen, but it is not severe but moderate. So the individual having moderate degenerate will survive up to adulthood about 40 years, and after that the degenerate may cause death, may lead to death of the individual. Finally, when both the alleles are normal or healthy, this one leads to homozygous recessive, means leads to a healthy individual. So this is the difference between the autosomal dominant and autosomal recessive Mendelian disorders. Clear? So we will make two different crosses now by taking different situations how the parents carry the disorder to their offspring. So first let's see about autosomal recessive. In this case what will happen? So I will make a Punnett square to show this condition. First let's take the homozygous dominant or healthy father and a heterozygous healthy or carrier mother. This one is a carrier mother. So we have this condition. So from the male or the father we will have two different types of sperms, and from the mother we will have two. Here let me write with black marker, and here we will have two different eggs from the mother. So the condition will be here capital H, here capital H, here we will have capital H, small h, here also capital H, small h. So the condition here we will find as a result of cross between the homozygous dominant or healthy father and heterozygous healthy, means carrier mother. The offspring that we obtain from this cross, we will have 50% of healthy individuals and 50% of carriers. Okay, so we can take different conditions and make different crosses to find out the proportion or ratio by which the children will be affected or carrier or healthy. Okay, so we can make another cross like this. Look, when we have a homozygous recessive father, means these are the sperms, and a heterozygous healthy or carrier mother, these are the conditions of eggs. So what will be the outcome here? We will have capital H, small h, capital H, small h, small h, small h, and small h. So by the cross we can obtain two different varieties of offsprings. One is carrier healthy, means heterozygous healthy, and 50% will be homozygous recessive, or they carry the degenerate. So these are the conditions. We can make different crosses. The probability can be taken from these three, and we can get different offsprings, and we can understand by making Punnett square what is the percentage of affected or carrier or normal individuals. Likewise, in case of this autosomal dominant, we will make crosses now, and let's find out what will happen in this case. So here the homozygous dominant is having the disease, severe version of the disease. Heterozygous disease degenerate is having the moderate version. So let's take a homozygous dominant father. Homozygous dominant father, we will have two sperms which carry the gene responsible for causing the disorder, and a heterozygous disorder or moderate version mother. So the eggs will be capital H and small h. So let's find out what will be the result. Here we will have the capital H. Here we will have also the capital H. Here we will have capital H and small h. Here capital H and small h. So from this we can conclude it by the cross between the severe condition and carrier mother. We will find severe condition means individuals having the homozygous dominant disorder and heterozygous disorder or moderate version of the disorder. So this is the difference between the autosomal dominant disorders and autosomal recessive disorders. We can take different forms of parents and find out their offsprings and the proportion. So this is the basic concept about the autosomal dominant and autosomal recessive disorder, and in my next videos we will detail study about the different Mendelian disorders, what are their causes and symptoms. Thank you very much.